The last topic we want to review is finding the average value of a function. So you know how to find the average value for 4 course exams. So if you have 4 exams, you add them up, you divide by 4. Of course, that's assuming that all of them are equally weighted, which is not actually the case. So for example, in our class, the final exam is worth more than the other exams. But the logic kind of holds true for equal exams. But the same logic also holds for computing the average value, i.e. the height of a function. So you imagine that you have some curve, f of x, and you want over this interval from a to b, and you want to represent one number that would represent this whole height, the average height for this. Just like you're using the average value here, right? That average value represents all 4 grades, right? That one grade value. So whatever the average is, it would be the equivalent of making that number each of these 4 numbers, and then that could represent your grade. We want the same here. I want one number that would represent, and that number is called f bar. F bar is the symbol, actually it's the symbol in statistics class as well. X bar equals the average of those 4 values, right? So F bar is the average function value. It's one value, one height that would represent the middle height of this curve. And so the way it figures that out is it finds the area underneath the curve, right? So we find that area right here, this area right there. That's the net area of the, or excuse me, that's the area under the curve, which is the integral from a to b of f of x dx, right? That's that area. And then let's think about this. If I want to find the height of that rectangle, I want to be able to take that integral right here, this lovely integral right here, and I want that integral to be equal to the area of this rectangle, because this rectangle would have this extra bit over here, which will compensate for this bit up here that would be lost. Now the rectangle is, well, it's a rectangle, so it's length times width, so, or base times height. So I would have base times height, right? Ooh, wrong color, sorry. Base times height. I'm going somewhere with this. So what's the height of that rectangle? Well, the height of the rectangle is f bar, right? And the base is the distance from A to B, which is B minus A. I want this rectangle to be equal to this area. By definition, if I can do that, then that height is the average height, the average function value, right? So let's say it again. This net area under the curve is equal to this net area of the rectangle. If I can make that happen, then the height of the rectangle will be equal to the average value of the function. So all I have to do is rearrange it. I want this integral to be equal to base times height. So in other words, the height of the rectangle would be equal to 1 over the base times the area, the net area under the curve. If I can do that, then the height of that rectangle will be equal to the average function value, right? Because average by definition would mean the one value that would represent this curvy function for that whole region from A to B. So this curvy function from A to B is best represented by that height right there, because that height would make it so that the rectangle and the region are the one and the same. The rectangle being this bit right here. Fascinating, huh? All right, this is a very, super useful, incredibly useful, very useful for finding the average value of any kind of function. So in other words, if we have applications, so I want to find the average cost, I want to find the average speed, I want to find the average velocity, etc. Well, we totally can, as long as we can compute the definite integral from a to b. All right, so let's practice this. So I have a function, which I have actually drawn in Desmos for us, and that function, I want to look at it on the interval from -1 to 2, and that's what I have drawn here. And I love when I tell you to draw a graph, and I already have the graph drawn, so that's kind of funny. All right, so I want the average height. I want to know what it is. So the average value would be f bar. F bar, by definition, is the integral 1 over b minus a. I think I'm just going to do all this in purple, sorry. Okay, so it's 1 over b minus a. That's the height, base, area. Okay, well, luckily for me, they actually gave us the values for a and b right in the problem. They tell us they want us to go from -1, hello a, to 2, hello b. All right, so this would be equal to 1 over 2 minus -1. Yes, I know that's terrible mathematical notation. I will fix it in a minute. And then that's the integral from -1 to 2 of x to the 4th minus 4x cubed dx. Okay, so this is 1 over 3 because 2 minus minus 1 is 2 plus 1, which is 3. And then I'm going to take this integral. So x to the 5th minus 4, and that'll be x to the 4th times 1/4. Oh, that's fun. Oh, and then 1/5 right here. Right? So we add 1 to the power, multiply by the reciprocal. Add 1 to the power, multiply by the reciprocal. And then I don't need a c, right, because this is a definite integral. I'm going to go from -1 to 2. Now, before I go substituting into this, I'm just going to realize that I could cancel the 4's and kind of make that go away. So I don't really need to worry about that because that's gone. All right, so then this is 1/3, 1/5 times 2 to the 5th minus 2 to the 4th. So all of that, 1/5, 2 to the 5th minus 2 to the 4th, all of that minus, and then I do it again, 1/5 -1 to the 5th minus -1 to the 4th. All right, well, I mean, we can use our heads and we can use Desmos, whatever, right? So I'll go use Desmos, might as well. Might as well show us how. All right, so I want 1/5 times, and I'm literally just using arrows to kind of move over. So 2 to the 5th minus 2 to the 4th. Now, if I want that in a fraction, I just have to hit this little fraction button right here. And it tells me it's -48/5 or -9.6. I'll use the fraction. So I'll say that's -48 over 5 minus, I'm going to do the same thing. And the beautiful thing is I can just kind of copy and paste. So it is going to be -1 to the 5th. Of course, I have to make sure that it's nested inside there. And then minus -1, because otherwise my negatives won't be distributed properly, to the 4th. All right, let's see if I did this right. 1/5 times whoop, I screwed that up. All right, 1/5 times -1 to the 5th minus -1 to the 4th. There we go. So -1.2. I think I had it already, but I just wanted to be careful. And that's -6/5. Okay, so -6/5. Okay, so moving back to my paper so you can see it. So I wrote the negative 48 fifths minus negative 6 fifths, which of course is plus 6 fifths. So this is 1/3 times negative 48 plus 6 would be negative 42 fifths. 3 goes into 42 14 times. So this is negative 14 over 5. Or if you like a decimal, then negative 2.8. Now let's think about what this means for just a second. What we did was we found that over here it's positive. There's a positive area. And then over here, it's a negative area. And there's a lot more negative area than there is positive area. So it shouldn't surprise us that our F bar average value is negative. And in fact, it's negative 2.8, which is almost negative 3. So this is 2, 4, 6, 8, 10. So 2 and 4, so 3 is right about there. So negative 2.8 is also right about there. There's our F bar value. This purple rectangle here has the same area, the same net area as the blue and the pink curve put together, right? So the blue and the pink kind of cancel each other out for a certain bit, right? They make 0 if you go there, right? That's 0. And then all this extra bit is equal to that purple part right there. Fascinating, huh? Okay, so let me show it to you in Desmos as well, because I've already got it drawn here. So let me go right here. So you can see there's the blue piece, there's the pink piece, and then if I look at the average value graph, there's F bar, right? That value of that purple is equivalent to the net area of the integral divided by b minus a. And of course, if I wanted to look at the calculations, I could in fact find it. Matter of fact, you can even type it. If you've named your f of x function right here, and you've named a and b, which I did, I said a was negative 1 and b is 2, then I can actually just type the function value and tell me that it's negative 2.8 or negative 14 fifths right there. So using function notation and naming things in Desmos is very much to your benefit. Remember that we use Desmos through the entire course as our calculation machine.